Right now, autonomous Tesla Robotaxis are crashing roughly 4 times more often than human drivers in Austin. And surprisingly, the solution to this safety crisis isn't, necessarily just better AI code.
Right. It's actually about what happens when the car parks, which
Yeah,
sounds crazy, but it's true.
it really is. Welcome to the deep dive, everyone. Today we are looking at a really fundamental shift in the world of transportation.
Yeah, a massive shift.
If you think about the electric vehicle revolution, like a human lifespan, we have officially survived the infancy phase.
Barely, but we made it.
Right. For a decade, the focus was purely on the miracle of birth. Like, could we build a car with a massive battery that actually looks good and goes fast?
And we proved that. We definitely did.
We did. But now we are hitting the highly complex and honestly very awkward teenage years.
Which is a pretty chaotic phase for any industry, really. The teenage years of the EV transition, they're all about systems. The focus is no longer just on manufacturing the metal and, mining the lithium. It is about figuring out how to make this hardware function independently, reliably, and eventually completely autonomously out in the real world.
And we've got a really fascinating stack of material today to help you, the listener, understand this exact shift.
Yeah, a huge stack.
We're pulling from everywhere. We're looking at the 2025 California Air Resources Board reports, new global regulatory compliance checklists.
The leaked crash data from the NHTSA, which is wild.
Oh, absolutely wild. And also some recent multi-million-dollar robotics funding rounds. Because, look, whether you own an EV and you're just tired of pulling up to broken public chargers, or maybe you're an investor trying to read the tech market, or you're just curious about what your commute's going to look like in 5 years, you really need to understand the hidden bottlenecks happening right now.
Because the industry is desperately pivoting to solve what is basically a massive logistical nightmare.
Right, so let's start right there. I mean, driving an EV is this incredible experience right up until you are far from home and you desperately need a public charger.
Yeah, then the anxiety hits.
Exactly. So what do the actual numbers look like right now regarding that friction? You mentioned a nightmare, but what's the data say?
Well, it's fundamentally driven by a sheer math problem. Like, the demand for charging is vastly outpacing the physical infrastructure we actually have in the ground.
Okay, so it's a bottleneck.
A huge one. We can look directly at the February 2026 data from ChargePoint to see the scale of this. Across their entire network, charging sessions jumped 34% year over year.
Wow. 34% in 1 year.
Yeah. They now have over 1 million drivers using their network every single month. And just as a quick environmental milestone, they estimate that usage has helped avoid 714 million gallons of gasoline.
I mean, those are massive figures,
Yeah.
714 million gallons. But earlier you mentioned that math problem. If sessions are up 34%, where exactly is the squeeze happening?
The squeeze is on the installation of the new hardware itself. So while the usage jumped 34%, the number of new ports on their network only grew by 16%.
Oh, wow. So demand is growing at literally more than double the rate of the supply.
Exactly. It creates what we call a textbook utilization squeeze. When the use of a system grows at more than double the rate of your physical capacity to support it, while the entire system begins to strain and crack.
Which perfectly explains why you see lines forming at charging stations now, or, people pulling up to find chargers out of order just because they're being run nonstop.
Right, they're just getting burned out. And the pressure is intense across the board. The 2025 annual report to the California Air Resources Board from Electrify America, it shows the exact same trend.
What are their numbers looking like?
In California alone, they saw a 24% increase in gigawatt hours dispensed and a 14% increase in actual charging sessions.
So the grid is just getting hammered. Yeah.
And to keep from drowning under all that demand, Electrify America is pouring $200 million into their Cycle 4 plan.
200 million.
Yeah, which basically involves ripping out a lot of older tech and upgrading stations to Generation 5e equipment, which is capable of those really fast 350 kilowatt speeds.
Okay, so upgrading the hardware makes total sense. You need beefier equipment. But there is a deeper market pivot happening here beneath the surface, isn't there? Like, it seems like the industry is realizing that the old business model of just, selling a piece of metal to a gas station or a parking lot owner, that's completely broken.
Oh, it is entirely broken. I mean, think about how commercial airlines operate.
Okay.
Decades ago, an airline would buy a jet engine from a company like GE, right? If it broke, the airline had to figure out how to fix it.
Which sounds like a headache.
A massive headache.
Yeah.
So eventually, they shifted to a model called power by the hour. The airline doesn't actually buy the metal engine anymore. They pay GE a continuous fee to guarantee that a working engine is on that wing, producing thrust.
Oh, I see. So they're buying the uptime, not the object.
Exactly. If it breaks, GE is on the hook to fix it immediately, and the EV infrastructure world is making that exact same pivot right now.
And the financial projections for this are just wild. This is called the EV Charging as a Service market, or CARES, right?
Yes, Karis with a C.
Right. And according to a recent 2036 global market analysis, this specific sector is projected to grow from $2.6 billion in 2026 to $16.8 billion by 2036.
It's explosive.
Yeah, that is a massive 20.5% compound annual growth rate. So the hardware-centric model really is dying.
Yeah.
Instead, what, 55% of the revenue in this new market comes from subscription or pay-per-use fees?
Right. And another 42% is driven entirely by fleet charging services.
Because consumers and fleet managers just don't want to own a charger.
No, why would they? If a charger breaks at a local grocery store, the store manager has absolutely no idea how to fix a liquid-cooled 350 kilowatt power cabinet.
Right, they're busy running a grocery store.
Exactly. So the driver gets angry, the grocery store looks bad, and the EV brand suffers. So instead, the site host buys a copy-S subscription. The provider handles the software updates, the grid balancing, the maintenance. The host just pays for guaranteed uptime.
I do want to push back on this a little bit, though, because it sounds like we built a massive, incredible theme park, but we only opened half the turnstiles to get in.
Okay, fair analogy.
Right. Because if utilization is outpacing new ports by nearly 20%, like we just said, won't this as a service subscription model just be putting a financial Band-Aid on a fundamental lack of concrete and copper cables?
That's a great question, but it's less of a Band-Aid and more of a total reallocation of risk.
How so?
Well, you are entirely correct that we need more physical cables in the ground, but the as-a-service model ensures that the capital being deployed actually results in functioning infrastructure.
Oh, because they only get paid if it works.
Exactly. If a provider's revenue is directly tied to a per kilowatt hour usage fee, they bleed money every single minute that a charger sits there broken. It forces the entire industry to prioritize bulletproof reliability over simply throwing as much cheap hardware into the ground as possible just to claim market share.
Okay, that makes perfect sense. The financial incentive is finally aligned with the driver's needs. And this connects directly to the government's role, right? Because regulators aren't just sitting back with their fingers crossed, hoping the market fixes these broken chargers.
Not at all.
The days of the Wild West of EV charging seem to be officially over.
Yeah, the tone from regulatory bodies has shifted remarkably fast. We went from governments offering carrots to wielding very, very heavy sticks.
Which we can see in this December 2025 compliance survival checklist from an industry group called VVEV. They make the current reality very clear. Regulations have flipped from just being guidance to strict enforcement.
Right. They act as a literal filter for market entry now. You can't just play around anymore.
Take the U.S. EV program, the National Electric Vehicle Infrastructure Program. It has aggressively shifted away from being an install and get paid subsidy. It now mandates a strict 97% uptime.
And we really need to pause and define what uptime actually means under these new rules because it changes everything.
Right. It's not just about the power being on.
Exactly. Historically, an operator might have a charger that was physically capable of dispensing electricity.
Yeah.
But if the credit card reader couldn't connect to the cellular network, the customer couldn't start the session.
Right.
The operator would look at their dashboard, see that the power module itself was fine, and count that station as online.
But to the driver standing in the freezing rain, swiping a card that won't read, that charger is 100% broken.
Precisely. Under the new NEV rules, payment errors and communication failures explicitly count as downtime. If the customer cannot successfully dispense energy for any reason, you are penalized.
Which is huge. And Europe is going even further with this. Under the EU's AFIR regulations, charging stations are now legally classified under consumer protection domains.
Which gives them a lot more teeth.
Tons of teeth. Any public charger over 50 kilowatts over there must have ad hoc payment capabilities, meaning standard card readers. You can't force a driver to download a specific app or create an account or buy some forced membership just to get enough juice to get home.
That is such a relief for drivers.
Plus, the operator has to display transparent upfront pricing per kilowatt hour before the car is ever even plugged in.
Which forces a massive technological overhaul behind the scenes. Because to meet these standards, companies can't just bolt a credit card reader onto a dumb metal box anymore.
Right.
They have to upgrade their hardware to meet strict safety protocols like UL 2202, which governs how high voltage DC power is handled safely. And on the software side, they're being forced to adopt OCPP 1.6.
Okay, wait, break that acronym down for me. What is OCPP 1.6 and why does it matter to you or me as a driver?
Sure, OCPP stands for Open Charge Point Protocol. Think of it as the universal digital language of charging.
Okay.
In the early days, a charging network spoke its own proprietary language to its own chargers. Now, the government is saying everyone must speak OCPP 1.6.
So it's like a translator.
Exactly. It ensures that a Ford vehicle, a Tesla network charger, and a Visa credit card transaction can all instantly talk to each other without timing out or throwing an error. But upgrading legacy stations to speak this new language is incredibly expensive.
Which is exactly what Electrify America noted in their report, right? They successfully hit a 95% weighted average uptime on their new Gen Lafitte chargers that actually have this modern architecture built in,
Yeah.
but their older legacy equipment lagged behind at 93.22%, which really shows how hard it is to drag old hardware into this new regulatory era.
It is. And honestly, this is going to trigger a massive wave of market
I
consolidation.
think smaller companies will get bought out.
Oh, absolutely. Smaller, underfunded charging networks simply do not have the capital to deploy 247 maintenance teams to hit that 97% mandate. Nor can they afford the hardware overhauls for UL 2202 and OCPT 1.6.
It's too high of a barrier to entry now.
Right. You're going to see a lot of smaller players either go bankrupt entirely or just get absorbed by massive, highly regulated utility-style companies.
So the industry has basically gone from getting a participation trophy just for installing a plug to facing a strict restaurant health inspection where you get shut down for a dirty kitchen.
That's a great way to put it.
But I do wonder about the side effects of this. Like, does forcing a 97% uptime mandate actually stifle innovation? If a company risks losing their subsidies for downtime, won't they be terrified to test new experimental technology out in the wild?
Well, it definitely stifles a specific kind of innovation, reckless innovation.
Okay, fair.
The public highway system is no longer a sandbox for beta testing. If a startup wants to test a radical new charging cable, they need to do it in a closed laboratory. Because when a family is relying on that charger to get home at 2 in the morning, they aren't looking to participate in a science experiment. They expect a utility that works as flawlessly as a traditional gas pump.
That is a very fair point.
Yeah.
Public infrastructure needs to be boring and reliable.
Exactly.
But speaking of experimental technology, hitting the harsh reality of public infrastructure, we have to talk about vehicles that don't even have a human driver to plug them in. Let's look at Tesla's Robotaxi program.
Yes. This is where the physical infrastructure bottleneck meets the AI bottleneck.
On their January 2026 earnings call, Tesla laid out a wildly aggressive expansion plan for the Robotaxi. They touted 700,000 paid miles since launch and announced they are expanding the service to Dallas, Houston, Phoenix, Miami, Orlando, Tampa, and Vegas.
It definitely paints a picture of imminent global scale.
It really does. But the reality on the ground is drastically different. A Reuters investigation from May sent reporters to test the service in these new markets, and the results were rough.
Very rough.
They experienced 2-hour wait times in Dallas. The vehicles were actively avoiding highways, like taking 35 minutes to navigate side streets for a trip that usually takes 20 minutes. And in Houston, the service area was restricted to these tiny, heavily geo-fenced pockets.
And the underlying cause for all of those inconveniences is actually found in that leaked crash data from the NHTSA filings.
Right. The numbers are staggering. In Austin, which is their primary testing ground, Tesla's Robotaxi has a crash rate of roughly 1 in every 57,000 miles. To put that in perspective for you, the human average is 1 crash in every 229,000 miles. So the autonomous system is crashing roughly 4 times more often than a regular person. Even Elon Musk admitted on the earnings call that safety validation is their actual limiting factor, not how fast they can build the cars.
And we really have to differentiate between a convenience problem and a structural safety ceiling here.
What do you mean?
Well, when a passenger has to wait 2 hours, or the car takes a bizarre back road route, the public just thinks the service is glitchy, right?
Yeah, they just think it's annoying.
Right. But Tesla isn't keeping the fleet small because of low consumer demand. They are artificially suppressing the scale of the fleet because their specific approach to autonomy is struggling with edge cases.
Let's break down that approach. Why is Tesla struggling while a competitor like Waymo is currently doing, 500,000 paid rides a week across 10 major cities? What is the mechanical difference between those two?
It comes down to how the car senses the world around it. Waymo achieves its safety scale by heavily relying on LiDAR.
Okay, LiDAR.
Yeah, LiDAR essentially shoots out lasers to bounce off objects and create a definitive high-definition 3D map of the environment. So the car knows exactly how far away a pedestrian is because the laser physically measured the distance.
Got it. And Tesla doesn't use that.
No, Tesla insists on a vision-only approach. They rely entirely on standard cameras, trying to build an artificial neural net that can see and interpret the world exactly like a human brain does.
But humans get blinded by sun glare or, struggle to judge depth in heavy rain.
Yeah.
Do the cameras suffer from those exact same issues?
Yes, and that is the core of the problem right now. Vision-only systems struggle immensely with edge cases, things like sudden lighting changes, complex shadows that look like solid objects, or judging the exact speed of oncoming cross-traffic at highway speeds without the definitive depth measurement of a laser.
That makes sense.
Waymo proved that autonomy is possible right now if you use heavy, expensive sensor crutches like LiDAR. Tesla is betting that once they solve vision only, it will be infinitely cheaper and more scalable.
But the NHTSA crash data shows that right now, their cameras are hitting a hard safety ceiling when the speeds increase. So Tesla's insistence on vision only without LiDAR is currently acting as a massive bottleneck. But let's assume they figure it out. Let's just fast forward and imagine a world where the AI works perfectly and we have millions of robotaxis from Waymo, Tesla, and whoever else operating seamlessly.
Okay, picture that world.
That brings us to a completely separate, massive physical hurdle. If you have 3,000 Waymo vehicles doing 500,000 rides a week, who is physically putting the plug into the socket at the charging depot at 3 in the morning?
Right. The entire illusion of full autonomy completely shatters the second the battery dies and a human has to walk out into the parking lot.
It totally defeats the purpose. It's like buying a state-of-the-art Roomba to vacuum your house, but forgetting to invent the self-emptying dock. If you have to follow it around to empty the dustbin every 10 minutes, it's not truly autonomous.
No, it's just a chore.
Exactly. And this is where the rise of the robot refuelers comes into play. We looked at a company called Roxy's, which just secured a $13 million Series A extension, bringing their total funding to $56 million.
They are directly targeting this exact logistical gap.
Their new M1 system is so fascinating. When you hear robotic charging, you probably picture a mechanical arm bolted to the ground next to a charger.
Like a gas pump that moves.
Yeah, but the M1 is an overhead, rail-mounted robot.
Which is mechanically superior for a fleet depot for several reasons. I mean, a floor-mounted arm takes up valuable parking space, it can get run over by a careless driver, and it's exposed to dirt, snow, and debris down at ground level.
Right, so this overhead system uses AI computer vision to look down and detect when a vehicle parks. The robotic arm slides along the ceiling rail, lowers down, opens the charge port flap, plugs the cable in, manages the charge, and unplugs it, without a single human involved.
It's incredible to watch.
And because it slides on a rail, one single robot can serve up to 10 different parking bays.
And when you look at their return on investment for a massive fleet operator, the math is just incredibly compelling. A 50-bay charging depot using this overhead rail technology can achieve up to 75% higher operational efficiency.
75%?
Yeah, that translates to roughly $1.7 million in annual savings, purely from eliminating the manual labor of human workers walking around plugging and unplugging cars all night.
And it's not just for small passenger robotaxis either. Roxy's received major investment from Scania Invest, the venture arm of the massive commercial truck manufacturer. So this technology is being prepped for heavy-duty trucking fleets too.
It's scaling up fast.
But I have to ask, if an overhead rail jams or the computer vision glitches, you haven't just lost one charger, you've instantly knocked out 10 bays. Are we just creating a new, highly complex point of failure in our infrastructure?
It is a significant single point of failure, yes. But that is exactly why the charging as a service model we discussed at the beginning is the glue holding all of this together.
Oh, because of the risk reallocation.
Exactly. In the depot of the future, the trucking fleet operator isn't buying the Roxy's arm, and they aren't buying the power cabinets. They are buying a KCAS contract for guaranteed charged vehicles.
So it's the provider's problem.
Right. If that robotic arm breaks, the service provider takes the financial hit and is contractually obligated to deploy immediate redundancy, whether that means sending a human technician out instantly or routing the trucks to a backup facility. The risk is completely reallocated away from the fleet owner.
Man, this has been quite the journey today. We started by looking at the sheer frustration of broken public chargers and realized that a 34% spike in usage is forcing the entire industry to abandon the old model of selling hardware, pivoting instead to guaranteed service subscriptions.
Mm-hmm.
From there, we saw how regulators are dropping the hammer, instituting strict 97% uptime mandates, and forcing complex software like OCPP 1.6 to ensure consumer protection.
The rules are finally catching up.
They are. Then we looked at the autonomous bottleneck, discovering that Tesla's limited robotaxi rollouts aren't just software glitches, but a symptom of their vision-only AI struggling with high-speed edge cases compared to Waymo's LiDAR. And finally, we looked up to the ceiling to see overhead robotic arms preparing to fully close the loop on autonomy, removing the human element from the charging depot entirely.
When you pull all those threads together, you really start to realize that the charging depot of 2030 will likely be entirely devoid of human operators. It will be a completely automated ballet of autonomous vehicles and robotic infrastructure communicating in real time.
Which leaves us with a final thought to mull over. As we watch the infrastructure become fully robotic and as the vehicles slowly conquer the AI edge cases to drive themselves, we are moving rapidly toward a perfectly closed-loop transportation grid.
A fully closed loop.
A system where machines talk to machines, flawlessly managing power usage, traffic flow, and safety. So at what point does the human driver become the actual liability in that system?
That's the real question.
10 years from now, will manually driving your own car and manually plugging it in be viewed not as a personal freedom, but as a dangerous, antiquated risk to the grid and the road?
It really forces us to ask how society will adapt when the machines can definitively prove, through raw data, that they are just safer and more efficient than we are.
The teenage years of this industry are definitely messy, but adulthood is coming fast. Thank you so much for joining us on this deep dive. Keep your eyes on the road, keep questioning the world around you, and we'll see you next time.